All right. Starting now. While some last people are dropping in, let's get started. My name is Marit van Dijk. Thanks for having me again this year. I'm here today to talk to you about reading code.
And before you start, I wanted to say one thing. Marit is the freshest Java champion, and this is her first talk as a Java champion.
No pressure. Thank you. Thanks. Yes, so no pressure. I'm here today to talk to you about reading code. I just want to remind you, if you have any questions, you can ask them in Slido, and we'll see if we can find them at the end. And if we have time to answer them, otherwise I'll be around for the rest of the day and tomorrow morning. So I'm here today to talk to you about reading code because as software developers, we spend more time actually reading code than we do writing code. We read code as part of lots of tasks like adding features, fixing bugs, when trying to understand a new system, when doing code reviews, when learning new technologies, etc. It's part of most of our tasks. In fact, developers on average spend as much as 58% of their time comprehending existing source code. This is a quote from the book The Programmer's Brain by Feline Hermans, who is a professor at the Vrije Universiteit Amsterdam. And she's a professor in computer science education. So she researches teaching programming. And she wrote a book called The Programmer's Brain, which is subtitled What Every Programmer Needs to Know About Cognition. And I'm going to use some of her work in this talk. So while we spend more time reading code than writing code, we don't spend a lot of time practicing that skill. Who here learned programming by writing lots of code? Don't be shy. All of us. So, and I remember when I learned Java at university, I would write a program 1 week, it would work, and then the next week I wouldn't remember how it worked because, you know, you end up forgetting. I'm a little bit better now, but it helps to practice reading code. So this is Feline in action. She did a talk at Strange Loop 2019 called How to Teach Programming and Other Things. I love her talk. She's very enthusiastic about what she does. But in this talk, she mentions a study from the early 90s where they were teaching a class and they were teaching the students programming concepts. And they split the class into 3 different groups. One group would write code and read code. One group would write code and read code with explanations of why that code was written that way, or why certain solutions were chosen or certain implementations were chosen. And the last group would only read the code and the explanations. And what they found was that actually the second and the third group, so both of the groups that read code with explanations on why that code was written that way, learned the programming concepts better than the first group who was just writing code and reading code without any explanations, which is not what we would expect at all, and also not how we teach programming. So after she gave that talk, someone came up to her and asked, so what if we practice reading code explicitly? And that's how Code Reading Club was born. They got together and every month or so, they pick some random piece of code from the internet, you know, GitHub is full of it, in different programming languages, and they do deliberate exercise, or they do deliberate practice with structured exercises where they look at this code and try to figure out how it works. And when I heard about that, I'm like, that's amazing, I want to do that too. And I got really lucky because a friend of mine actually contacted me and said, hey, we're starting a code reading club, do you want to join? I'm like, yes, I do. So I joined a code reading club. And what we do is we get together every month virtually because we are in different countries. Some are in the Netherlands, some in Germany, some in the UK, some even in the US. We have different roles. Some are testers, some are developers, some are coaches. We all use different languages, Java myself. Someone else uses C#. Someone brought some PLSQL one time that they were working on. So we bring a code sample, print it out, and then use the structured exercises to annotate the code, basically, while trying to figure out in the end, so what does the code do? And this is a picture I took of one of the actual pieces of code that we use. So you end up with a very merry, colorful piece of code at the end. And I really, really loved being part of this code reading club, or I still do. And I loved deliberately practicing reading code and what we could learn from that. But I also really loved having all of these different people with different experience and different viewpoints, and the things that they noticed about the code, or the things that they understood about the code or didn't understand about the code, and the questions that they came up with. And I kind of almost liked getting all of the different perspectives more than just the practice of reading code. So I started also giving code reading workshops at meetups and conferences. But then would get the question, so, but what about the IDE? Normally I read my code in my IDE. So I want to, in this talk, do a bit of a mix of what are some of the structured exercises that you can use and why, and how can your IDE help you. I want to also focus on reading code to understand it, not to critique it, because these are different mindsets. And also I need a meme in my slide deck always. So if you're doing a code review or you're looking at code thinking, how would I do this better? That is a different mindset than what does this code actually do? How does it work? How did it come to be? Because nobody sets out to write bad code, even though if we look at it now, we might think this is bad because it's not what the current paradigm is, or it's not how I would write it. Or it's not how I would write it now. I've also seen code I've written 6 months ago and went like, there's some room for improvement there. So let's look at some of the reasons that code can be confusing. Code can be confusing for a lack of knowledge. If the language that you're reading is unfamiliar, or the code constructs that are being used are unfamiliar, you lack knowledge to be able to understand the code. You might have a lack of information. You might not know what the concepts are that are being used in the code, or what the domain represents. And finally, you might have a lack of processing power. There might be so much going on that it's just too much for you to process at the same time. There are several ways that we can deal with this. If the problem is lack of knowledge, that can be either in the business domain, because the domain is new to you, or in the programming domain, because it's an algorithm you haven't seen before, or, like I said, code constructs. Dealing with that lack of knowledge, while reading a piece of code, it might help you to create a list of the things that you don't know, or the questions that you have. Research those. So some you might need to look up right away in order to even be able to read the code. Some you might be able to park for a little bit and research later. And some might be worth studying or memorizing. If it's a code construct that you see more often in the code base, it might be worth memorizing that and storing it in your long-term memory so that you can retrieve it next time you need it. Lack of information might be unknown details. Say there's in a piece of code that you're reading, it uses a standard method, but you don't know the details of that method. You could go look that up, but you don't have it right here. There might be unfamiliar names, there might be abbreviations in the names, and you might not know what they mean if the domain is new to you. Code might be connected in unknown ways, or there might just be too many things going on at once. This is related to our short-term memory. And as you might know, our short-term memory can only hold a limited number of items. And we used to think that it was 7 plus or minus 2, but it turns out that it actually might be less than that. It might be just 2 to 6 things. So it might help to group information into concepts that you can then store in those slots. So, for example, I'm going to use a very basic example so everyone can follow along. If you've never seen a for loop, you might think, oh, we have a for loop, we have variable I usually, We have an where we need the loop to end, and we increment it by something. If we are not familiar with the concept of a for loop, we might store each of those in a separate slot in our short-term memory, and it will get full quite quickly. If we're familiar with the concept of a for loop, it will take up only one slot. So chunking information together and seeing what concepts are represented in the code rather than the small details will help manage this lack of information in our short-term memory. Finally, a lack of processing power. If there's just too much going on to fit in our brain at the same time to process, we might get overwhelmed. And the way to deal with that is by using memory aids, for example, a dependency graph or a state table. So a dependency graph might look like this. This is an example from Code Reading Club where they used apparently Erlang. So what you do is you annotate the specific variables and methods, etc. Excuse me. And then connect them to see where they are used. And from that, you kind of get a view of how the flow of the application works. You can do this either on paper if you print out the piece of code, or you can use an online annotation tool if the code is online, on GitHub, for example. And to get a bit of an insight in how the application flows. You might have seen or used state tables before. So if you have a nested loop, for example, again, deliberately using a simple example, you might trace the values of the variables in this loop. You might have more complicated examples, but you'll be able to use this to trace the values of the variables through your application. So when we are trying to understand a piece of code, structured exercises can help us. And to give you some examples of the structured exercises that we use in our Code Reading Club. If you're confronted by a piece of code and you're overwhelmed and don't even know where to start, the first glance is, that's literally how the exercise is called, is a good place to start. What the exercise is, you take 1 minute to look at the code and just note down what the first thing and the second thing is that you notice and why you notice those things. And the result of that can actually be quite interesting, because we noticed in our Code Reading Club, sometimes people notice, oh, this is familiar, which gives me a hint of what this code might do. Or, oh, this is something that I don't know, so I might need to look into that to get a hint of what this code is doing. Also, there's usually people who are always trying to figure out what language is this, which will then help them figure out what the code does. So if you're completely overwhelmed, you have 1 minute, do this exercise, and that will give you a place to start. The next one will be to identify components and the relationships between those components. So like we just saw in the image, select all variables, connect which variables are used where, and do the same for methods and the call stack, and you'll get an idea of how the control flow of the application works. Another exercise that we do is to select the 5 most important lines in a piece of code, which also led to some interesting results, because what does most important mean? This meant different things to different people in our club. So for example, I mentioned we had some testers in our group. So some people were like, these lines means that I have stuff to test. So those are the most important ones. I really like that. Other people said, okay, these lines give me the best idea of what this code is even about. For example, a class name might give me an idea of what this code does. Or a comment might give me an idea of what this code does. Other people selected, these are the lines that define the control flow of how the application does what it's doing. So it might also depend, which lines are most important to you might depend on what task you're performing at that time. But usually you're reading code with a specific task in mind, so training to find the most important lines will help you figure out what code does more quickly. Another exercise is to identify concepts represented in the code. You can create a list of those so that you can check whether you already understand these concepts or whether you might need to do some research and come back to the code to really understand what it does. And while none of these exercises focus on the meaning of the code and what it does directly, at the end there's an exercise where usually we try to summarize what does the code do, and people tend to be able to approximate what the code does without having looked at that specifically, just from having done those specific exercises. Of course, those exercises were fairly basic. They're still very useful, I think. There might be more in-depth exercises that you need to do if you have a piece of complicated code. One such exercise is to discuss the roles of variables. Feline discusses this model of the roles of variables in her book. And someone did research on what the roles of variables might be and came up with this framework of variables can have one of these, I think it's 11 roles. So if you have a piece of code with lots of variables with different roles, this might be an interesting exercise to do. And there are more and more exercises in her books, and Code Reading Club has resources also on GitHub where you can find more exercises. So some might be more applicable to your particular piece of code that you have at a certain time. And you can do them either in a group or with your team or individually. So when we're looking at a piece of code in our code editor, usually we have syntax highlighting. So we don't need to figure out what variables are and what methods are, because the IDE will do that for us. When we are reading code, we tend to scan code, because we don't read code like a novel from start to finish. We tend to scan and look for chunks of code and see if we can figure out high level what the code does before looking into the details of, for example, what a particular method does or whatever. And we tend to also learn this over time. So more experienced programmers do this more than beginner programmers. Of course, your IDE supports looking at the structure, and it might have features for you to collapse code or expand code depending on what you're looking for. Also, if you're looking at code in the IDE, you're able to restructure the code. I don't know if anybody's ever done an Oracle Java exam like the OCA. They give you code samples that are, I think, deliberately malformed or poorly formatted, which makes it more difficult to understand. So if you're reading code in your IDE, you can reformat the code, you can restructure it to your liking to make it easier for you to understand. In the IDE, you can also look at the behavior of your code, so you can see if there are tests for a particular piece of code. Hopefully the tests will have names that explain the intended behavior. And you can run them through the debugger to observe how your application works. And finally, you'll have context. So if you're looking at one piece of code with structured exercises, you have just that one piece of code. So if it's calling methods outside of that class, you don't have that information. In your IDE, of course, you can navigate there. As well as have the context of how the code came to be. You can look at the version control history to see when code was created, hopefully maybe also why that code was created. In my previous job, we would also always link it to Jira tickets so that you could go look for the information of why particular code came to be. So let's look at some of those things. Let me also grab my cheat sheet. So if you're looking at code in your IDE, you'll have syntax highlighting, as we mentioned. Can you read this all the way up top? Yes, no, maybe? Thank you. So we can pull up documentation about the classes that are being used right where we need it. We can also jump to the source But if you end up doing that, you might end up getting lost and bogged down into details. So it's nice to be able to have that information right where we are. We can get information about a return type if we need it. In this case, the return type is covered by the name of the class, but that isn't always the case. We can search for variables and how they are used throughout the class, but we can only look at one at a time. So if we want to do the dependency graph, it's much easier to do that on paper. So you can trace multiple variables throughout the application or throughout the piece of code. As mentioned, we can collapse the code and expand only the thing that we want to look at, which we can't, of course, do on paper. We can restructure, we can move stuff up and down. So reading code in the IDE is much easier. And we might also, no, that is not what I wanted. We can also run the application and see what it does. In this case, that won't work. So let me find another application. Yes. So if we have a class that we're looking at and we want to look at the behavior of that class, we can open the corresponding tests. We can open them side by side. So hopefully the tests will have names that somewhat express the behavior of the application. We can run them through the debugger to understand, to see how the code behaves, sorry, I can't English today apparently. So what the control flow is and how it runs through the code. And finally, we can, as mentioned, hang on. We can look at the version control history, where we can see when a commit was done, when this code was changed, what else was changed in that particular commit, and maybe even have the AI assistant explain a commit to us or use other kind of tooling to help us understand the commit history. So when we read code in our IDE, we have all kinds of hints that we can use to better understand the code. Of course, it's on you to focus on the things that are relevant to your current task. So in this case, the AI assistant tells me that this particular commit was done for SonarQube rules, which I maybe would have put in the commit message, but that's me. So the next thing is you might want to look at a particular slice of the application that is relevant to your task. So depending on what you're trying to do, maybe you're trying to understand a particular code base, maybe you're trying to add functionality somewhere, change functionality, or fix a bug. You'll look for a place to start. If you're trying to understand how the application works, that might be a generic place to start, like a main method or an endpoint. If you're trying to accomplish something specific, like fixing a bug, you might look for where an error message is thrown. You might look for where an exception is thrown. If you're trying to change functionality, you might look for where that logic is or where that functionality is, and also where it's used in the application. So you'll need to search for that place and then navigate from there, tracing it through your application. So, like we said, one place to start would be the main method. Although in the case of a Spring application, who uses Spring? You know that the main method is where the Spring magic starts. So it's not a very useful place to start if you're trying to figure out a Spring application, but for different applications it might be useful. So for a Spring application, for example, you might look for a controller class and then trace it from there and see what happens. So for example, the endpoint we just looked at, if it has errors, then it will return a view. If not, it will save this owner. So we can go from saving the owner to the repository and back up again. I'm using the Spring Pet Clinic as a demo project, or as an example project, which is a demo project by the Spring team. It's fairly simple. So in your actual applications, you might have more layers. So you might have a service layer with a bunch of business logic in between. In this case, it goes straight from the controller to the repository and back again. So you can trace one slice of the application. If you're trying to, for example, fix a bug and find where an error message is written, you might look for that particular error message. See what is happening there, see how, and then trace it back up. You might want to look even where you are in the application. So you can find where is this particular piece of code located in my bigger application, and hope that that helps you basically put you are here on the map. So there are all kinds of ways that your IDE can help you with searching for particular pieces of code and then navigating from there. And finally, if you're onboarding to a new team or a new code base, you might need to first get an idea of what the code base even does. So this might be if you have a new job, or you're switching teams at your current place, or you want to contribute to an open source library or a shared code base in your company. You'll need to figure out what that code base does. A good place to start is by checking out the code and making sure that you can run it. If it's a code base that you'll need to work on, you want to make sure that you're able to run it and build it before you make changes. Ask me how I know. So that's a good place to start. My last team that I joined at my previous job actually had as an onboarding task, check out all of the repositories, make sure that you can build them. You'll find out whether you have the right stuff installed, for example, as well. If you're joining a new team, hopefully someone will be able to explain you a bit of the context about what does this team do, what code are we responsible for. In my last job, most teams were responsible for multiple microservices. So for each of those microservices, hopefully one of the people on the team can explain, this is what this service does, this is the place in the landscape, these are the other applications that it interacts with, these are our users, to give you a bit of context of the stuff that you cannot get from the code. And they might also be able to tell you, look specifically at these parts of the code because we change them a lot, or maybe ignore these parts of the code because we barely ever touch them, you can look at it later, and all kinds of pointers. So vice versa, if you have people joining your team, make sure to do that so that they can onboard faster. When you're looking at a bigger code base and trying to understand it, it also still helps to identify the components and the relationships between those components, so different modules or different packages, and it helps to identify concepts that you might not be familiar with. Just like if you're looking at a small piece of code, it helps to understand some of the concepts in a bigger piece of, or in an application, that will give you a larger overview, and that will help you also chunk some information if you're working on it. So finally, we'll look at some ways to help you with that. So in the Spring Pet Clinic, for example, there's only one module, And there are only a few packages. So if we want to figure out what this application does, we have a hint in the title already. It emulates a pet clinic. So we have a model, we have owners, pet owners, we have vets or veterinarians, and we have some classes that are more system related. So if I need to make changes in this code base, there are only a few places to look. It won't be hard to find the right place. If we're looking at a larger code base, like I'm using Cucumber JVM as an example, which is a library for behavior-driven development, that works with a bunch of other tools. You can run it in different ways, either from the command line or using JUnit or TestNG. So it connects with a lot of other libraries. And it has a bunch of modules. So if I wanted to figure out what this code base does, I would need to figure out what each of these modules are. Now I happen to know that they have, each has a README that will explain that particular module, but I'd have to go over all of the modules. So I'd be looking for a way to figure out what would be a good module to start. Obviously, the one called core might be a good place to start, but where do I go from there? So from there, I could figure out what dependencies does core use. So start from core and then look into the other modules that core uses. But it might also be helpful to be able to visualize that. So for example, we can use automated tools to help us visualize dependencies in a code base. Can you still read this up top? Thanks. So here we have a dependency matrix, which has all of the same modules that we see in the project window. But sorted by dependencies. So the ones on the bottom are the ones that are actually being used by the ones on the top, as we can see by the blue boxes that represent the dependencies. And as we can see in the legend, green uses a dependency which in turn uses the yellow dependency. So if we, for example, click on core, we see that core uses several other modules and is used by a bunch of other modules. So we can use that to create a mental model of the application. Or of course, we can use tools to generate diagrams for us. Automated diagrams can help provide information on relationships between modules, or we can generate UML models to find the relationships between classes. If you're lucky, they're not too big and you can actually read them. If you're unlucky, they might get very big to the point where it's actually very hard to read them. And while you are able to navigate in these diagrams, and we can actually search for things, this doesn't really help me understand the code much better, but it's information that I can use to get a better picture. It's still recommended that you draw your own diagrams, because then you can focus on the part that you're actually actively working on, so the slice of the code that you're looking at, as well as you'll be able to remember it better because you're actively working with the information and processing the information. Research has shown that you retain the information better if you're drawing your own diagram than if you're automatically generating it. In addition, if you're onboarding to a new code base, something that I usually do is I look for the build file to see what dependencies are being used, to see if there are any that I don't know yet, and add them to my list of things to research, and maybe look at the documentation for some libraries to see what they are and how they are used. Maybe search the code base also for where they are used. You might want to run an application. No, I don't want to run the test. I want to run the application. So you might want to run the actual application to see how it's used. Let's see if I can open a browser. Puppy tags. So we can look at the application and see how it's used. We can look at the outside in. We can also, in this case, they added an error that we can take a look at to see how it works. Which we can also have the AI assistant explain to us what type of error this is and what it means. And finally, we can also ask an AI assistant or ChatGPT or something to explain code to us, if you find that helpful. It takes a while for the response to come in, though. So I'm not going to wait for that, I hope. There's my presentation. So we looked at, I think I forgot to mention that it's helpful to run your application, depending on whether you're using Maven or Gradle, or if you're not doing JVM, other build tools, you might have a standard way of building your application. If not, you might look for that information in the README of your project. I once worked on a team where every application was built differently. But none of the READMEs would tell me how, so I would start adding that to the READMEs so that I could remember, okay, this project I build in this way, that project I build in that way. You want to look at the project structure, dependencies between components, and diagrams. So what's next is, I hope that you are at least interested in doing code reading exercises and that you found those helpful. I have added the details of the exercises that I mentioned at the end of my slide deck. So you can find the slide deck on my website with also links to the Code Reading Club. They currently don't have any online sessions planned, but keep an eye out for when they do. Or start your own based on the starter kit that they have provided. Yeah, and that's it. So now we have to see whether there are any questions in Slido. So I don't know if there's anyone from the organizers here that can maybe facilitate. I don't know if you have Slido open because it's taking me a while. Yes, that's faster. Where can we find some code reading clubs? So, okay. Mind if I continue with this one, or should I? So there's the online code reading club, the link of which is in my slides and on my website. It's literally codereading.club. They have online sessions. They used to have monthly sessions, but I think they stopped over summer, and they currently, I checked this morning, they don't have any sessions planned. So the alternative would be, I think Felina does some online code reading clubs on O'Reilly, if you're a member of that platform as well. Or the alternative is to start your own. And the Code Reading Club does have a starter kit with resources available that also my code reading club used for the very first session. So they actually have like 3 or 4 sessions all set up for you with a code snippet, which is actually, it's harder than you would think to find a code snippet that fits about 1 page. So that you can use that for your exercises, because it's really helpful if you can print it on 1 or maybe maximum 2 pages. So they have like 3 or 4 sessions all set up for you. So then the next challenge becomes finding some friends or coworkers who are also interested in trying this out. It can be really useful to do with your team because you learn about each other's code reading ability, backgrounds, what you notice about code. It can also help you if you're having a lot of discussions during code reviews on code styles, where sometimes people have emotions about the code that they have written, and discussions might not be productive. Or might be hard and to have about code that you've written yourself or that other people have some kind of feelings about. So it can actually help you by doing exercises with code that you didn't write to see if you can resolve some of the discussion points on code style, etc. So I would highly recommend that. So where do I go? It's GeeCON. Or if you can tell me the next question. Do I see AI assistance as a big game changer? Aren't you afraid of it providing bad interpretations for information? Yes. I'm not sure if I see it as a big game changer, but I know that a lot of people are very enthusiastic about it. I try to show some ways that you can use it where it might be useful, that were also relevant to my talk. I've also heard other use cases where it might be useful, like a coworker who uses it to generate test data, which sounds like a good idea or a good use case. In the case, I've used it to explain 2 of my example projects that I used. One was Spring Pet Clinic and one was Cucumber JVM, thank you. The Spring Pet Clinic is a very standard project. So it explained that quite well, because percentage-wise, it's going to get that right. A lot of Spring projects built with Spring will be web applications, and it understands which technologies are used in that project. So it can give me a pretty good summary of what that project does. I've also asked it to explain Cucumber JVM to me, which also uses Spring somewhere, and then it confidently told me, this is a web application. No, it's not. And I had to add a lot of prompts and provide it with additional information before it started to make sense. So it can be useful. For example, I did like the way that it would summarize which technologies were used in the Spring framework, but it can also be confidently wrong. So you still need to at least know some stuff yourself to be able to evaluate the things that it's telling you. So in that sense, I don't know whether it's going to change our lives forever, because we'll still need to understand the things that it's telling us, and we'll still need to evaluate what it's telling us. I got the question last time I did this talk, do we still need to be able to read code now that we can just have AI build it for us? To which my answer was, do you want to copy the code that the AI gives you without checking how it works? Kind of like, do you blindly copy stuff off Stack Overflow? Currently, please tell me no. Because once you copy that code and you check that in, that is now your code. So you better understand what it does. So I hope that answers the question. What code annotation? Oh, I think I might have skipped one. But it's the first one I saw. What code annotation tool can you recommend? So the Code Reading Club actually have an online annotation tool. It takes a little bit to get used to it. So I actually personally prefer printing and using colored markers, also because you get to play with colored markers. But if you go to the link that I provided on my website, So if you go to my website, that will have links, and either on this page for this talk, or if you go to my page for code reading workshop, we'll have a link to a code annotation tool that you can try. And that works with code that is hosted on GitHub. What's my experience with pairing mobbing as a way to create a shared understanding? Great, highly recommend. If you have a team that works well together. If you have a very high power imbalance, it might not work as well. But I've done some pairing with a team that works really well together, or even just pairing with a teammate on a particular subject and sparring and bouncing ideas off each other, and both the knowledge sharing and the sharing the understanding of what we're actually building and the solution were better for it. How do I go to the... Yes, thank you. Do you read only good code or all kinds of coding art? Creative code, I'm taking that as creative. Interesting. Like you, all kinds, including some of my own bad code. So it would be really helpful if we could have great code that we could aspire to, and we do. We have all kinds of projects on GitHub written by language creators, by framework maintainers, and we can use that as examples of good code that we might aspire to. There are also, of course, everybody shares their everything, including my graveyard of GitHub projects that I haven't maintained since 2017 or stuff like that. So all kinds. And in your work life, you will encounter all kinds. Even though people don't set out to write bad code, it might not be up to your standards, and you'll still have to make sense of it. So I would definitely also recommend practicing reading bad code. Can I recommend some epic legendary code to read? No, not right now off the top of my head. I'm very sorry. I'll think about it and let you know if I think of any. IntelliJ has nice class bean diagram tooling which comes in quite handy. Do you know any tools for sequence diagrams, if you find sequence diagrams useful? I used to use... I forget. I used lots of UML tools some time ago when I was in university, which is quite a while ago now. Drawing by hand, I think we used Microsoft Visio. I don't know if that's still a thing that did UML diagrams. Sequence diagrams can be useful. I think also some of my ex-coworkers used drawing diagrams in Confluence. I don't know if they used sequence diagrams, but I also find just drawing stuff by hand super useful. I find just drawing decision diagrams when you're trying to figure stuff out, even when before you're coding, if you're discussing a story, just writing a decision diagram to figure out whether you have all of the information for all of the arrows, for all of the diamonds, for decisions that you're making. I hope that made sense. When you read code together, how does that work out? One person talking or? So when we do a code reading club and we read code together, we will have exercises. So we'll have a sample of code that whoever is hosting that session brought in. And there will be exercises where part of the exercise will be everybody individually take 1 minute to take a first glance and write down what you notice. Sometimes it will be, let's all together decide on the roles of the variables in this piece of code. So it depends on the exercise. How long are the code samples you analyze? Are you allowed to check tests to guess what the code does? So for Code Reading Club, the samples will be 1 or 2 pages, which comes down to roughly 70 lines of code. Which is not a lot, so just finding a sample that is small enough is quite difficult. We use a printed version, so it will be usually on a piece of paper or a PDF. Sometimes we have it online. We don't actually check the tests for that piece of code. I don't think we've ever done that in our code reading club. And I've not needed it because from the exercises that we've done, we do always tend to gradually come up with an idea of what the code does. And also that becomes more of a collaborative effort where if there are syntax that some people don't know, usually someone else in the group will be able to explain. If there are concepts that someone doesn't know, someone in the group will be able to explain. Some people also brought code that they had written themselves, so then obviously they can provide the context and answer any questions that people might have. What about tools like ArchUnit? Do they help to understand code better? I've only ever briefly used ArchUnit, so I can't really comment on that, but that's an interesting question. Can GPT do adequate reading? I'll leave that as an exercise to the reader. Out of curiosity, what is the source of the Rust code reading Erlang coming in the early? That is a screenshot from Code Reading Club. I don't know where they got it, but it's either on their website or on their meetup page. And it was a good example of showing you what the dependency graph looked like. So that's why I used it. Reading Club looks like a brilliant tool set when diving into nightmare ancient legacy monsters. Yes, it does. Whoever wrote that, please give it a try and let me know how you get on and if you find it helpful. Thank you.